So to start things off, we're going to have a look down into our pit of spikes here, and our first trap is basement design. So we're going to talk about a couple of things on basement design before we move up throughout the building. So we have a look down, and our first topic is hydrostatic pressure. Probably a term that a lot of you are familiar with. It's the reason why basements leak most of the time. And it can cause some pretty significant issues on a building. Nice simple diagram here shows how that water, in this case from actually ground level, presumably rain or else other surface runoff, has actually infiltrated down and is starting to build up. And water has weight, quite a lot of weight in fact. And when you allow it to bear against a structure, you start to get these sort of issues. Right, that's a block wall. Another very similar one here as well. 4-foot block wall just buckling in internally. And you all might have seen these sort of structural failures. I'm going to talk to you about a very unique type of failure that I'd come across surprisingly about 4 or 5 times in the last 12 months. This exact same scenario has occurred, or a very similar variant of it. And I'll explain how it went about. So we had a project with a shoring wall, right? And this varied between projects. Some it was a secant pile wall, others it was a diaphragm wall, others it was a CSM wall. Anyway, it was a shoring wall. And the geotech engineer said, hey guys, like here's our report, we've done all our analysis, everything like that. You've got a problem with water on the outside. But look, I see on your structural diagrams that you've got this type of wall, like secant, for example, that they should be actually able to withstand hydrostatic pressure and stop the water coming in. Right, so here's a nice little diagram there. This is what should happen. We've got our okay, now I need the pointer. Got our shoring wall here, and water should not be able to infiltrate past it. The builder at the time said, that's awesome, that's the exact advice we want to hear. Now we can just sort of do, whatever we want. We've got water taken care of, right? What actually happened was this. Oh, and I should mention that there was actually, to tidy up the look of that wall in front, there was a 70mm shotcrete wall, which is the darker color here, applied in front. And actually, for good measure, on some of these, the builder even added in some water stops at junctions, and they added an additive to make the shotcrete watertight. Right, so there was effort there. But what actually happened was this. No one bothered to or did the appropriate due diligence to talk to the shoring wall contractor and ask them if they were, because there's a big difference between what something can achieve and building it to achieve that on site. Differentiating factors between the type of soil and how well it retains your piles and everything will create a varying confidence. And what you'll find is a lot of shoring contractors wouldn't give a warranty for certain types of shoring walls, but that check wasn't made. There was no warranty or accountability. It was all optimism, which was pushing this. So what actually ended up happening was water was able to infiltrate, very slowly actually, through this wall. And then hydrostatic load ended up being applied to our shotcrete surface here. And hydrostatic pressure can build up 1 drop at a time. But as it does build up, this is what's happening.